Hello, everyone, and welcome to learning discussion about algorithms and the flowcharting process. The objective of this learning session is to learn about the flowcharts and the process of flowcharting and how it is applicable across various disciplines as a computational thinking and a problem solving process. It's also to learn about how we can develop a flowchart from an algorithm and last but not the least, learn to create a few flowcharts of processes we encounter in our daily life. So let's begin. You already know an algorithm is a mathematical method of solving problems, uh, be it big or small. And though computers run algorithms constantly, humans, which is us, can solve problems, seemingly simple and or complex problems using algorithmic thinking. So a flow chart is a diagram that uses shapes, lines, and arrows to sequence steps. It is a visual way of representing the input, output decisions, and calculations that take place within a program. There are many benefits to including flowcharts as part of your curriculum. This is because this task of flowcharting forms a meaningful connection to the real world. In the workplace, flowcharts are often used by programmers to organize and share ideas. In fact, they are so useful that most professions use them to communicate how a process works, including engineers, scientists, manufacturers, business managers, and even healthcare workers. Hi, I am Rashmi. I am one of the instructors for this course. I also direct the digital learning and library program at Arlington Public Schools, and I serve as a director of innovation and learning with C-STEAM Futures, and I also work with the Leslie STEAM team at the Leslie University. Um, let's talk about flowcharts. So, for example, when beginning program development, many programmers find that outlining the flow of information and process visually helps to devise a coded solution. The flowchart provides a rough outline because it becomes a practical tool for identifying variables, pinpointing errors, connecting code, and fine tuning ideas. Similar to programmers, a student receives the same benefit when they create their own flowcharts. Another practical purpose of flowcharts is the workplace, especially in the workplace, is that they can be used as a visual aid for non programmers, such as clients or investors. Having a documented framework of a program transforms an abstract idea into something tangible that everyone can understand. The flowchart becomes a reference point when explaining how the design works. It also is a concrete way to notice elements that are missing or ideas that require further clarification. For students, the outcome is similar. Producing a flowchart is a visual way of demonstrating to the teacher, the professor, or to your client an understanding of the programming concepts. It also frames a discussion about design elements and, in general, coding. Yet another reason sometimes K 12 teachers should include how to make a flowchart within their curriculum is to develop computational thinking. Computational thinking is a problem solving process, as you know, that has four parts: decomposition, pattern recognition, abstraction, and algorithm. When designing a flowchart, each of these parts are blended to produce a valuable learning opportunity. When teaching and learning about how to make a flowchart, it is important to explain that shapes have meanings. There are very certain specific and exact symbols that we use when we are creating a flowchart, some of which are listed right here on the slide. These symbols are standard. For example, an oval is used to illustrate the start and end of a program, whereas a diamond shows a decision such as yes or no. This is very critical because if we do not use the standard symbols, then we cannot communicate the effectiveness or the logic of the program to another programmer or another audience who doesn't have the same standard understanding of the symbols. Here is an example of all of the flowchart shapes or symbols that you can use. So you have the oval, which is the start or the end, which is called a terminal. You have the input and output, which is a parallelogram to show the input and output. Input could be the user entering information, and output could be a message on the screen. There's also a rectangle to process an action. It could be a formula to calculate a value, or it can be a step that modifies text. Then comes the diamond to make decisions. This shape will not have two or more lines that come from it, one for each outcome. This step might ask a question or provide options, and the result could be true or false, yes or no, or choices. It could be red, blue, or green. I apologize, I said that this shape will not. Instead, this shape will have two or more lines that come from it. And last but not the least are the flow lines or the connect symbols. And we use these lines to connect the shapes, and the arrows show the direction of the steps. Some lines should include labels such as yes or no to explain what exactly is happening. So this is a quick cheat sheet for the flowchart shapes and symbols, which will be attached into your readings and also into this in this video. So let's go to our next slide. Um, so let's begin by looking at a simple task to create an adding machine such that sums of two numbers. Okay. So a calculator is something familiar to all of us. It is on every phone and computer. Since it is recognizable, you can transfer this existing knowledge to this particular task. This enables students to focus their attention towards organizing the program components into a flowchart. This is, again, an ideal start point because it introduces a new skill in a non threatening way, and students can practice computational thinking without the strain of too many complexities. So, and this also allows them to gain confidence as they break down the program into individual parts, classify them by type, start, end, input, output, process, and decision, eliminate irrelevant details, and sequence the steps. Um, let's look at, so in here you can see that we have a start block, then we tell the player about the adding machine. Players enter two number, they process the calculation, which is they sum the numbers, display the answer, and end. So that's your simple task and a simple flowchart for that. Now let's expand the knowledge about our flowcharts to include a decision making with branches. Once students understand the basics of building a flowchart, they're ready for a more complicated task. It is now time to introduce a program that includes decision making. This requires branches to illustrate the outcome of different options. In addition, some of the flow lines that connect the shapes will need labels to identify their purpose. To gradually develop expertise, this task should only have two choices, such as true or false or yes or no. A task that will engage students in a guessing game. So players must correctly pick a number between 1 and 10 to win. Although this program only has a few steps, it uses all the standard shapes in a flowchart and also has branches. Now we are going to move on to applying pattern recognition to the existing loop instructions. Okay? So designing a flowchart with a loop requires students to apply pattern recognition to notice the repetition within a program. Instead of listing steps over and over and over again, a flowchart lists them once and then shows a decision that controls whether a sequence repeats. The loop can be a predetermined number of repeats, such as cheering Yahoo 3 times. Alternatively, it can be controlled by a value, such as if a player selects a play again. Here we have started with a simple loop that only has one step to repeat. Now we are going to, in our next progression, add a loop to repeat many steps within a program. This design is more complicated, as you can see. There are many steps of shapes and lines going in multiple directions. To avoid confusion, this task is best done with your audience that has a little bit of a firm understanding of flowcharts, hence the steps previous to these. A good idea is to add a loop to an existing flowchart, such as the above mentioned guessing game. For example, players can decide if they want to play again. Designing a flowchart from scratch is indeed a challenging activity. It is a task that requires not only logical and analytical reasoning, but also the ability to think abstractly. Computational thinking can be introduced to younger children using a wide range of learning strategies. Now, let's look at this program. You have a start block, then you tell a player about the game, then you have a rectangular block where you are talking about how the game picks a random number between 1 and 10. So it's a process 1. Then you can see that you are going between these. You have an option. If it's yes, you play again. Player picks a number. So right after this, you go here. Player picks a number. Then once the player picks a number, if the player is correct, yes, you are right. If the player is wrong, then it will go. You will get you are wrong, right? There is also the possibility of game picks a random number between 1 and 10, and if yes, you can play again. No, then you end. If it's yes, you go back and you start this game all over again. So that's how you sort of add additional looping to this program. Here are a few examples, real life examples of flowcharts. I just want to re-emphasize that nevertheless, the act of building a flowchart is best suited to children probably from middle school and up, and those in grade 6 and up, because developmentally, older students are at a stage where they can understand abstract ideas and explore multiple solutions to a complex algorithm. But you can start as early as fifth grade, sort of introducing the idea of flowcharting. So let's look at this real life example of flowchart. This is a process flowchart from Nestle Toll House chocolate chip cookies. And you can see that there is a start terminal, there is a stop terminal, you have the recipe, and then you have specifics assigned to your, as we have shown you, the rectangle is about processing or processing in action. So you can see that we have an action right in here, which is a preheat oven, combining mixed batch, and then you have notes right around it about specifics for that process. So you can see we have three process blocks. We also have a decision block where if the oven is preheated and yes, then you can bake cookies. If not, then you wait for the oven and go back into the loop and actually wait for the oven to get heated, then bake cookies and hopefully eat those delicious yum cookies after you stop. So this is one example. I'm going to show you one write-up about how a company, a startup, a Japanese startup, Flutterscape, used flowcharts to improve their shipment process flow. So you can see right here, there is a whole write-up about that, but you can see that there is a specific flowchart that they used and modified in order to improve upon their existing shipment process flow. Here is another example of a cooking recipe, and then one which is which is personally my favorite because I love cooking, is to how I should be cooking more and what are some of the ways and processes that I would go through in order to make sure I am cooking more. So these are a few examples. Now I have one which we are going to build together, and it also aligns well with the with one of the assignments that you might have about taking an actual recipe and turning it into an algorithm and then into a flowchart. So let's look at it. This is about let's bake some bread. Now let's understand the task, which is bake a loaf of bread. It's quite general statement. So the Suppose if I asked you to bake me a loaf of bread, what is the process that you would go through from the time I give you the task to the point when you give me the finished loaf of bread? So, the first step is to make sure you understand the given task. Bake a loaf of bread is quite vague and very, very general. Here are questions you should ask to clarify the task. What size of bread? Should it be simple bread or flavored bread? Are there any specific ingredients you have to use or avoid using? Are there any ingredients you don't have? What equipment do you need? Is the equipment supplied to you or do you need to get your own? Is there a time limit? Are there any recipes you can look up and use, or do you have to make one up on your own? It's important that you get these details right to avoid having to start the task again. If there are no further details on the task, then the solution you come up with should be as simple as possible and require as little work as possible. Look up a simple recipe instead of trying to come up with the correct combination of ingredients on your own. Bake a small loaf of bread, don't add any flavors or spices, and use a bread machine if you have one to save time. So, here is the process which we are going to look at for the recipe. And as you know, the recipe is the sequence. Give me a quick second. I am going to the slide. It is the sequence of steps that you must follow to bake the bread. So once you clarify any questions or misconceptions on the task, you can look up a recipe or come up with one on your own. The recipe tells you how to do the task. Coming up with the recipe on your own might be the hardest part of doing the task. Once you have a recipe to follow, putting everything together shouldn't be as difficult. Now take a quick look at any recipe right now. What I have included is in this figure is one of the recipes. It's a sample recipe. It's a rather simple recipe, and it includes the following information: what steps you should do and in what order, specific measurements, instructions on when and how many times to repeat a task, what substitutions you can make for certain ingredients, and any finishing touches on the dish and how to serve it. The recipe is a sequence of steps you must follow to bake bread. The steps are sequential. For example, you cannot take the out of the oven without first putting in the ingredients in the pan. At certain step, you can choose to put in one item instead of another, like either butter or canola oil, but maybe not both. Some steps may be repeated, like occasionally checking for the crust color before declaring that it is done. So there are some flexibilities within a recipe that you have where you can change ingredients or part of the process. Now let's visualize the recipe with flowcharts. When you read a recipe, the sequence of steps is likely outlined in words. To prepare you for understanding how to be a programmer, you should start to think about visualizing recipes with flowcharts. Here, you can see in the figure, it shows you how to represent baking bread with a flowchart. You represent steps in rectangular boxes, which is a process. If a recipe allows for a possible substitution, represent them or that with a diamond box. If a recipe has you repeating a task, draw an arrow going back up to the first step in the repeated sequence. As you can see right here, you have an arrow going right back up because you have a choice. And then that decision, is the crust black, is is a choice for you. And if it's no, great. Hopefully it is not no. This is a flowchart of a simple recipe of baking bread. Rectangular boxes represent doing an action, gray diamonds represent a decision point, and the dashed line represents going back up to a previous step to repeat a sequence. Follow arrows to trace path through different implementations of the recipe. So this is your input, right? You're adding all the ingredients. Then do you have butter? If yes, add a tablespoon. If no, add 1 tablespoon olive oil to the bread machine pan. Both of them converge, and then you click the start button, open the bread machine, check the crust color, and close the bread machine. Crust is golden brown. Nope. Crust is black. Oh no. You go back up, you open the bread machine, do all of that again. Or I would say you go back up and probably start making your bread all over again. In this case, crust is black, say oops, no bread for you, and then you go all the way back up here, as I said, and make your bread again. While as if the crust is golden brown, you can stop and then you can enjoy your recipe. So that's your flowchart from an algorithm to a flowchart, a visual representation of that algorithm. Now, many recipes for bread are out there, right? So to answer, use an existing recipe or do we need to make one up? Let's look at this. Many recipes for bread are out there. How do you know which one to use? With a vague problem statement such as bake a loaf of bread, all are good to use because they all accomplish the task. In that sense, a more general problem statement is many a times easier for you when you have a set of recipes to pick from because any of the recipes will work. If you have a picky eater and are asked to bake something for which there is no recipe, you will have a hard time accomplishing the task. You have to experiment with different ingredient combinations and quantities and with various temperatures and baking times. Like you will have to start over a few times. Just like in here, you might have to start over a few times um, for that process. The most common type of problems you'll be given is a specific task for which you have partial information, such as bake me a 2 pound rosemary loaf of bread using 4 cups of flour, 1 tablespoon of sugar, 1 tablespoon of butter, 1 tablespoon of salt, and 1 teaspoon of yeast. I'm sorry, you do not want to add 1 tablespoon of salt, you want to add 1 teaspoon of salt. So here you have a lot of critical information already in the task, but are missing a key piece. You have all the ingredient measurements except for the rosemary amount. Now the hardest part is to experiment with ways of putting the ingredients together and to determine how much rosemary you need to add. If this isn't your first time baking, then you've come into the task with some intuition, knowledge for how much rosemary is needed. The more practice you have, the easier it is going to get for you. The main idea is to understand from the baking example is that there is more to baking and cooking than following a recipe. You have to first understand what you are being asked to bake or cook or the task at hand. Then you must understand if you have any existing recipes or processes that you can follow. If not, you will have to invent your own recipe and processes and experiment until you have a final product that matches what was asked of you. In the next section, you will see how we work with that and translate this idea of flowchart into pseudocode, which will be in my next video. Here are some learning strategies for teaching flowcharts to your student. Describe the purpose, make a recipe, fill in the blanks, connect the shapes, list the variables, transform a recipe into a flowchart, and then we will make some code connections. To provide a solid foundation of understanding flowchart, you can introduce any of these concepts gradually. Here is another example of how we go from an algorithm to a flowchart, and this is a challenge where you are asked to draw a flowchart for an algorithm to add two numbers. And you can see that there is a variable which is essentially a container where you can store value that could be changed during the course of an algorithm or program. And in this case, a variable is also given a name, it's an identifier, while as in here, the identifier is number 1, right? Or number 2. Those are your two variables. And also answer, which is another variable or output answer. So just a second. You've defined two variables, number one and number two, and you're outputting the answer after adding the number one and number two. This is another example of an algorithm to calculate two different difference in two numbers, and then converting that into a flowchart, which is pretty self-explanatory. Again, you have two variables, and if number one is greater than equal to number two, true, subtract number from two from one, false, subtract number one from two, and then you store number as number three and output number three, which is the end and the end. So you can see the terminal blocks at both ends. We have talked about the microbit image rotation animation, and that's one way you can practice the algorithm and then converting it into a flowchart. But I believe you can take a recipe that you like and then you can convert that into a flowchart. And that would be a really fun little exercise that you can do with your kids as well, if you so choose. Thank you again. Have a wonderful day, and I hope we continue on our journey of computer codes, flowcharts, algorithms, and pseudocodes. Thank you.